Hey physics kids, online physics kids, how are y'all doing today? This is Mr. Goya coming at you today. I'd like to introduce Unit 14. This is our unit over electricity, and this is the introductory video here. We said physics is all about things that are in motion, right? And so we've spent quite a bit of time talking about constant velocity, acceleration, free fall, forces. We did a unit on energy and momentum. Electricity is kind of a little bit different, really, and you might want to say, well, what's really kind of moving with electricity? Well, what we have in a circuit is the motion of charged particles. Now, the charged particles in an atom are the protons and the electrons. The protons reside, as you probably know, in the nucleus of the atom, and electrons then are outside in orbitals. And so typically for what we're talking about here in high school level, in what we call DC electricity, direct current electricity, we're talking about the outer electrons. These are called the valence electrons that are in motion in a circuit. And so you might say, well, what does electricity have to do really with motion? Well, it's the motion of these charged particles. Another kind of alternate way really of talking about electricity is the creation and the production really of electrical energy and its use in a circuit. So really in all circuits we have a pathway. And as we'll find out in this unit, there's really two basic sorts of pathways we can put together, what's called series and parallel. But we always have to have some sort of a pathway. Now that pathway might be wires, or maybe we're transmitting electrons wirelessly. And a lot of that's being done now, like with the internet in your house or your apartment, etc. Typically then, if we talk about electrical energy, we have a device like a battery that's basically creating that energy, and then we have a device like a light bulb, for example, that's consuming that energy, or maybe we have some other device hooked in that's using that energy. There's really several types of electrical sorts of electricity, really. We can talk about what's called AC and DC. AC is what's called alternating current, and that's basically the type of current we have in our houses and apartments. And so AC current is sinusoidal, so it makes these sine waves. Now, the study of alternating current is beyond the scope of most high school sorts of classes. Now, the type of electricity that we're going to really deal with is what's called DC, or direct current. With direct current, that battery, for example, this battery provides a constant level of voltage, which is the push or the energy created really in a pathway. And so, for example, if we have a 9-volt battery, that voltage would be constant at 9 volts. So that's kind of DC. And that's kind of the type that we'll be studying in this class. Well, now there's really 4 main ideas with electricity, and you'll get to study this a little bit more on one of the resources, the website that I created for you. So the first concept is what's called charge. And again, this would be the protons or the electrons, the charged particles. For again, what we're doing in this course, we talk about the motion of the valence electrons. Charge then is given the symbol Q. And we measure charge in a unit called the coulomb. Now, the rate of charge, and remember a rate is something divided by time, the rate that charge is moving in a wire or a circuit is called the current. It's given the symbol I. Current then is measured in a unit called the ampere, just called the amp. So we're basically pushing these electrons from atom to atom, and we can divide that flow by time, or the number of charged particles per time, and we get this idea called the current. Now current then is measured with a device called the ammeter. I'm sorry to say, if we were in a, if we weren't doing kind of online, I could definitely kind of show you an ammeter, and we could actually hook up and practice hooking up real circuits. That's okay. Voltage then is the third concept. So we've talked about charge and charge per time, that's current. Well, then the energy input, or the push, that's kind of generating that force that's pushing these valence electrons from atom to atom, that push is then called the voltage. We measure that basically in a unit called the volt. And depending on the circuit, we might have different types of batteries in a circuit, different voltages. We measure voltages then with a device called the voltmeter. Notice the voltmeter, if you were to get an ammeter or a voltmeter, they look really kind of similar. This has a little A on it, that's an ammeter. And this one has a little V on it, that's a voltmeter. But they're hooked in really into circuits entirely different. Now some of you might have what's called a multimeter at home. And a multimeter can be switched, and you can measure a lot of different things with a multimeter. You can measure current, you can measure voltage, you can measure resistance, etc. Well, that brings us really up to the kind of the fourth concept. That's called the resistance. And let me get rid of that. This resistance is measured in a unit called the ohm. And that was named after, oh golly, what's his first name? That was named after George Ohm. He was kind of a German scientist. We'll talk about him here shortly. So typically we can put in what are called resistors, and this is what a resistor looks like. And we put resistors in a lot of circuits, a lot of motherboards, and a lot of different devices. Or we could use what are called light bulbs, and they act as resistors. They consume electrical energy. So in terms of like a light bulb, we basically want our electrical energy to create kind of a light for us. But there could be a lot of other devices that we could put in a circuit that uses electrical energy too. Well, part of the problem with current is when we talk about current, it's somewhat a dangerous sort of thing. If we have too much current, that can be pretty harmful. So often in circuits, we'll put in resistors, and that can lessen the current that's flowing in the device. Well, there's really not too many new equations for us. We've got this one that's somewhat important, and that's called Ohm's law. And again, there's a picture of George Ohm. And this was maybe about 1830, 1840, somewhere around there. Ohm kind of discovered that there was this relationship that existed between three of our four concepts. V equals IR, or the voltage, is equal to the current times the resistance. That's kind of the statement of Ohm's law. And we'll study that in the course of this unit. Now, as I mentioned, there's really two ways of hooking up light bulbs or resistors. These are the symbols for resistors, by the way. We could do what's called a series hookup or a parallel hookup. In a series, we have just one pathway. Okay, this is a symbol for batteries. So we have batteries, and we have resistors all hooked up end to end. That's a series sort of connection. And there's times that we want this type of connection. Well, we also have what's called a parallel connection. With parallel, we have different branches. So part of the current might go down this branch, part of the current might go down this branch. We still have our same batteries, but this parallel configuration offers some advantages to certain types of circuits too. And we'll be looking at both of these types of connections. So we really can't build circuits in the course, since we don't really can't really get the equipment to you, etc. But we can use simulations, and we'll be using, again, for quite a few of our activities, we'll be using the FET-DC circuit simulation software. Okay, well, that's kind of a quick highlight of this unit. Again, this would be Unit 14, DC electricity. I hope that's helpful. We'll talk to you later, kids. Bye.